Regardless of make or model, one of the most common repairs on any vehicle is bulb replacement. All bulbs have a limited lifespan, and since this is something we can all visually see, even if a vehicle owner isn't an automotive expert, it is a problem they're going to notice. Years ago, there were far fewer bulbs to choose from, but today there are a lot of choices and also a lot of questions you may have to answer when your customer needs a replacement bulb. One of the most important details to begin with is making sure the bulb is correct for the application, especially if your customer isn't experienced with auto service or has had multiple failures of the same bulb. All bulbs are designed to fit into a specific socket, or in the case of a headlight bulb, work with a specific connector. However, there are a limited number of socket and connector designs, so just because a bulb fits doesn't mean it's correct, and installing an incorrect bulb is a very common mistake. Why is this important? Each bulb is specified by the auto manufacturer for a certain wattage, which can be compared to the amount of power in the form of light the bulb can produce. The higher the wattage, the greater the light output, but that comes with higher heat. Sockets, connectors, and wiring are designed around specific circuit properties including bulb wattage, and a higher wattage bulb may produce more heat than the components can handle, eventually causing the socket and wiring to melt. In addition, when the incorrect bulb is used, it can cause circuit problems, inoperative lights, incorrectly operating lights, and even warning lights for computer-monitored circuits. Traditional incandescent bulbs, which utilize a filament that is heated until it glows, are still very common for automotive use. Some of these bulbs are available as long life bulbs, which typically means they have been designed with a slightly longer and thicker filament, slightly reducing current flow and temperature, increasing the life of the bulb. Some bulbs may also use different gases inside to increase the durability of the filament and increase the life of the bulb. While some long life bulbs may be slightly dimmer due to their construction, this is an almost unnoticeable effect, and these bulbs are worth the additional cost, especially if they are difficult to replace. Anytime a bulb is replaced, the socket or connector should be inspected for corrosion or damage, and this is often the cause of the problems. Dielectric grease is helpful in bulb sockets to keep moisture out and prevent corrosion. Most headlight bulbs come with a common warning not to touch the bulb during installation. Many people ask why. The natural oils on your skin will transfer to the surface of the bulb. As the bulb heats up, it expands. If there's oil on it, that spot will get much hotter than the rest, expand at a different rate, and cause it to crack or shatter. This is most relevant for headlight bulbs due to the heat they produce, but I like to recommend the practice for all bulbs. LED bulbs are a common upgrade due to their increased light output, but there are a few important details to keep in mind. LED bulbs draw less current, so you don't have to be concerned about circuit damage. However, they can cause warning lights to occur on computer-monitored circuits. And finally, when upgrading to LED, keep in mind that the housings and lenses for incandescent bulbs are very specifically designed to reflect and flood the light outward, since the light from the bulb is emitted in all directions. LEDs only emit light in one direction, so depending on their design, even though they may be brighter, they may not illuminate an entire lens assembly as intended by the manufacturer for proper visibility and safety of the vehicle. Thanks for watching.